Hi everyone. Now let's start with another LeetCode question. This is problem 1, 2 sums. Right. Given an array of integers, num, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Example 1. Inputs nums 2, 7, 11, 15. Target 9. Output 0, 1 because nums 0 plus nums 1 equals 9. We return 0, 1. Example 2. Nums 3, 2, 4. Target 6. Output 1, 2. Output 3. Nums equals 3, 3. Target 6. Output 0, 1. Nums length between 0 and 10 to the power of 4. Nums I between minus 10 to the power of 9 to 10 to the power of 9. Target minus 10 to the power of 9 to 10 to the power of 9. Only one valid answer exists. Follow-up. Can you come up with an algorithm that is less than O(n) squared times complexity? Great, thanks. I'm just thinking about what else could be relevant to know. Okay, I think I can think of one way off the top of my head to solve this. So we are given nums. And then we have a target. Now what we want is an indices of nums so that they add up to target. There is exactly one solution and only one solution exists. And we may not use the same element twice, so we need to pick up two that if add up together equals target. So you need to find the indices. I think one way could do this is that we can go through the elements and then we record the number that we have seen before. At the same time, we need to store the indices, the index number. And then, if in the future we found another number that adds up to target, sorry, let me repeat my answer. Let me repeat my explanations. If in the future we found another number that could be added up with the number that we have seen before, and they add up to target, then we return the index number that we have found for that number, for the previous number that we have found, and then the current index. Then we get the solutions. And one way that we can do that is we can use a dictionary, right? So we can use the dictionary to store the number as the key and the index number as the value. So in this case, by doing so, we can check whether we have seen a number previously that could add up to target that could be added to the current number that we have seen that add up and they add up. Let's say this. When we arrive at a particular number and also we have seen a number that could be added to this number and they add up to target, then we can use this dictionary. So this solves two problems here. First of all, we can use a dictionary to check whether we have seen a number, and also we can get the index number of that number, right? I'm thinking about the edge case where the nums, where there are multiple number that exist at different indexes. I'm thinking if it is gonna be a problem. I don't think so, because let's say we use the dictionary and then we update it to a new index, which is the latest index where we have seen a number. Then we can just use that number. So that is no problem. And I think it provides also flexibility to. I assume we can use whichever index number, and given that the number are the same, is it safe to assume so? Okay, I'm gonna assume that. Let's say we have two seeds at different index, then we need six as one of the number that could be added up to the target. Then in this case, I can use any of them. I think that's reasonable. Alright. Do you guys think I should proceed with the coding? I think I'm pretty good about this. So index number. Index number. So let's say initially we have index of x, and then it would be at position I, and then we later found the index of y equals I, let's say it's just j, and it happened that x plus y equals target. Then we return I comma j. Okay. So first of all, I'm gonna create an index. I think index is not that clear. I'm gonna say scene. Okay. So let's create a scene equals empty list. And then I'm going to go to all the num in nums. So let's say, so x plus y equals target. Then what we need the x to be is x equals target minus y. And then, sorry, forgot the indentation. Okay, let me skip indent. So let's say call x equals target -1. Then we check if x is in the scene. So if x in scene, then we can just return the index number of the x, which fortunately we have stored in the scene. So index, and then the current one, well, sorry, we need to know the current, which means that we can use enumerate of nums. So this should be j, right? So let's call it I here, I, and then this j, I, okay, because I'm sorry, I'm just used to I. Then we can return the I, right? And because we are sure that there is one correct solution, then we are confident that this function will return inside this function here. Oh, very important. We need to store. If it is not seen before, let's say x is not seen, then we just all we need to do is store the current value. Actually, so call this y. So since the y equals I, alright, let me quickly walk through the code to make sure I haven't missed anything. So first of all, I create the scene array, and then I'm gonna look through all the nums. Then I create a variable, which is what we need, so that it adds up to target, given that we use y as one of our solutions, one of the pair of solutions, as one of the return answer. Then I'm gonna check whether x is seen before. If so, then we have found our solutions. In this case, I'm gonna return scene of x, which will give us the index number of x, and also the current index that our current index, which is the index number for y. Then at that point we got our solutions. If not, then we record the current number index number. Right, so that's what we did in the last line. The scene y equals 1. Now let me test the code with our sample input to make sure it works as intended. Here the array is initialized as 2, 7, 11, 15 with target is 9. So in this case we start with scene, and then scene is empty, then we look through the queue, Now the index of 2 is 0, 7 is 1, 11 is 2. Wait, actually, 7 is 1. No, we have not reached that point. So 2 is 0. No, 2. And then the x. The x that we need for 2 is 7. 7 is not in there. And then we just add it to there, to the scene. And then the next time we see 7, which means the x is 2. Then we see that scene 2 is there. So we return the scene of 2, which is 0, and then the current index. Which is 1. So 0, 1. Which is correct. Now the second example that we have here. So nums is 3, 2, 4. Target is 6. Start with empty scene. And then we see 3. Target index is 0. 2 is 1. Now the x is 3, x is 4. Now when we go to the 4, the x is 2, which means we have seen it before. Then we are gonna return the 2, which is 1 and 2. 1, and then the index of the current number, which is 2. So solutions is 1, 2. Now the next one is num equals 3, 3. Target is 6. Scene of 3. Now the x is 3. Now this is 0. Maybe go to the 3, x is 3. Then we have seen the 3, which means we are gonna return 0.1, which is correct. Now the constraint should be good because we have test the edge case, which is two elements. I think this is also another edge case where the value are the same, and our logic should work because we don't put it before we check. Here we are checking. Then one thing that we forgot to do is checking the complexity. So here we are going to the element, so that will take us O(n), and then the space is also O(n). Actually, in the previous problem, I forgot to go through the complexity. So the time is O(n), and the space is O(n), which is the scene. Because imagine that we go through the entire array until the end, and then we find a solution. So meaning that we need to create a dictionary of n elements. I think this code should work. Now let's try to implement in our LeetCode interface. So first of all, scene is an empty array, and therefore I, y, let's call it x, in enumerate of nums. Then we have y equals target minus x. Then we check if y in sim return sim or where we see the y and also the current index. Otherwise, we record the current index for x. Got an error sim x. Right, so this should be a dictionary. Sorry about that. But we got an accepted cases. Let's try submit it. Yeah, we got an accepted answer here. Wow. Well, that's cute that we beat 100%. I'm not sure how worse we could do this, but anyway, thank you everyone.